This object entered our solar system from outside. It moved strangely, then it left before we could ever reach it. And years later, scientists still do not fully agree on what it was. That is what makes this story feel different. It did not hit Earth. It did not explode in the sky. It did not arrive as a giant, world-ending object with fire behind it. The disturbing part was quieter than that. It came from somewhere beyond our sun's family, slipped through the inner solar system, gave us only a short window to study it, and then disappeared back into deep space. Its name was Oumuamua, and even the name sounds like the beginning of a mystery. In Hawaiian, Oumuamua is often understood as a distant messenger arriving first. That meaning is almost too perfect, because this was the first confirmed object ever seen passing through our solar system from another star system. It was not a familiar comet that belonged near the sun, and it did not fit comfortably among the asteroids we already knew inside our own solar system. Its path said something more unsettling. This object did not belong here. That is the first thing to understand. Oumuamua was moving too fast to be captured by the sun. The planets in our solar system follow closed paths around the sun, and comets from the outer solar system can return again and again on long orbits. Oumuamua was different. Its path was open. It came in, curved around the sun, and kept going. It was not staying. That single fact changed the entire story. A normal asteroid can be strange. A normal comet can surprise us. But an object that enters from interstellar space is something else. It is not only a rock or an icy fragment. It is a piece of another history. Somewhere, long before we noticed it, Oumuamua was part of another environment, another star, another disk of ice, rock, and dust. Maybe another young planetary system in chaos. Then something threw it away. By the time it reached us, its original home was lost. That is why this object feels so hard to ignore. It was not only passing through space, it was passing through our only chance to know something about a place we may never identify. And we noticed it late. By the time astronomers discovered Oumuamua in October 2017, it had already passed its closest point to the sun. It was already leaving. Imagine someone walking through your house at night, and you only notice them after they are already going out the back door. That was Oumuamua. It had entered the inner solar system before we knew it was there. It had already swung around the sun. The moment we became aware of it, the object was fading away from us. That one detail should bother you, because science is powerful, but it is not magic. Astronomers cannot rewind the sky. They cannot force an object to come back. Once Oumuamua was on its way out, every observation became a race against distance. Telescopes around the world turned toward a faint, moving point. Scientists tried to gather whatever they could: how bright it was, how quickly that brightness changed, what color the surface seemed to be, and whether its motion matched the path gravity alone predicted. That sounds like a lot. For an object like this, it was barely enough. Oumuamua was too small and too distant to reveal its surface. We did not see cliffs, craters, cracks, or icy jets erupting from it. The famous images people remember are artist impressions, not close-up photographs. That is one of the most important parts of the story. The object everyone imagines as a long, dark cigar tumbling through space was not directly photographed in that form. Scientists inferred that kind of shape from the way its brightness rose and fell as it rotated. So the most famous picture of Oumuamua is not what we saw. It is what the data forced us to imagine. And that is where the mystery becomes more uncomfortable. The object was real. The measurements were real. The interstellar path was real. Yet the thing itself stayed hidden behind a few changing points of light. It was close enough to detect, but not close enough to understand. At first, Oumuamua looked more like an asteroid than a comet. When comets approach the sun, ice can warm and turn into gas. Dust can lift from the surface. A glowing cloud, called a coma, can form around the nucleus, and a tail can stretch away into space. That is the image most people have of a comet. Oumuamua did not show that obvious behavior. There was no bright, dusty tail, no clear comet cloud, and no dramatic spraying plume that made the explanation easy. For a moment, that seemed to settle the matter. Maybe it was just a dry, rocky interstellar asteroid. Then the orbit refused to behave perfectly. As astronomers tracked it, they saw that Oumuamua had a tiny extra acceleration. A small push. Not enough to make it turn around, and nothing like a spacecraft in a movie, but enough that gravity alone did not perfectly explain its motion. A normal comet can do this. Gas escaping from the surface can act like a weak natural thruster. The push is small, but over time it matters. Here was the problem. Oumuamua seemed to be getting pushed, but it did not clearly show the tail or dust cloud people expected from ordinary comet activity. That missing tail is why the story refused to die. If it moved like a comet, why did it look so quiet? That question opened the door to years of debate. Some people reached for the most dramatic possibility. Maybe it was artificial. Maybe it was a probe. Maybe it was a light sail. Maybe something intelligent had made it. Those claims became famous because they were loud. But the more careful story is not less strange. Most scientists looked for natural explanations. They asked whether Oumuamua could be a different kind of comet, a fragment with unusual chemistry, or an icy body whose gas release was hard to see from Earth. That is how real science works when the evidence is incomplete. It does not begin with the wildest answer. It tests what nature can do first. And nature can be much weirder than people expect. One idea suggested the object might have been rich in unusual ices. Another considered whether it could have had a strange shape or low density. Years later, a strong natural explanation proposed something especially interesting. Oumuamua may have contained water ice, altered by cosmic rays during its long journey through interstellar space. That process could have produced molecular hydrogen trapped inside the object. When it passed near the sun, warming could have released some of that trapped hydrogen and created the tiny push we measured, without producing a normal bright comet tail. That explanation does not make the object boring. It makes it stranger in a quieter way. Picture a fragment from another star system drifting for ages between stars. Cosmic radiation slowly changes the ice inside it. The surface becomes dark and processed. Then, after an enormous journey, it briefly passes close enough to our sun to warm, release hidden gas, and shift its path just enough to confuse us. No alien engine is needed. No impossible technology is needed. The natural explanation is already bizarre. That is the tone this story deserves. Not fake certainty, not a panic story, not a claim that we discovered alien machinery and science is hiding it. The real version is more elegant and more disturbing. A visitor came from another star system. It behaved in a way that did not fit neatly into our first categories. We observed it too late, watched it fade, and were left with a scientific puzzle built from incomplete evidence. That is enough. Actually, it may be more powerful than a simple answer, because a simple answer would have ended the story. Oumuamua did something better. It showed us that the solar system is not sealed. Objects from other stars can enter. They can pass near the sun. They can leave before we understand them. And if one was found in the short period when our sky surveys were good enough to catch it, the obvious question becomes much larger. How many came before? How many passed through when no telescope was watching? How many are crossing the dark right now, too faint or too badly placed for us to see? The solar system suddenly feels less like a private island and more like a road through a larger galaxy. That is the first layer of this story. Oumuamua was not frightening because it threatened us. It was unsettling because it proved that something from another star can enter our neighborhood, show us only a fragment of itself, and vanish forever. The first visitor did not give us a clean answer. It gave us a new kind of question. The strangest part of Oumuamua was not simply that it came from outside the solar system. The real problem was behavior. If the sun and planets were the only important forces acting on it, astronomers could model its path with gravity. That is normal orbital work. Measure the position, measure the speed, include the pull of the sun and planets, then predict where the object should go. Oumuamua almost followed that gravitational path. Almost. That tiny mismatch became the heart of the mystery. The object seemed to receive a small extra push away from the sun. In astronomy, that kind of motion is called non-gravitational acceleration. The phrase sounds technical, but the idea is simple. Gravity did not explain everything. Usually, when a comet gets pushed like that, scientists look for outgassing. Ice warms near the sun, gas escapes from the surface, and the object gets a weak recoil. It is not a rocket in the human sense, but the physical effect is similar enough. Gas leaves one side, and the body receives a small shove. A normal comet would usually betray itself. You might see a coma, you might see a tail, you might detect dust. The object would give clues that gas and material were leaving its surface. Oumuamua did not make it easy. The push was there, but the obvious visual evidence was not. That is where the case became strange enough for the whole world to notice. The simplest version of the mystery is this. Oumuamua looked quiet, but moved as if something had acted on it. That does not mean it was artificial. It means scientists had to ask what kind of natural object could behave that way. The answer did not arrive cleanly. Some possibilities sounded almost as strange as the mystery itself. Maybe it released gas that was difficult to detect. Maybe the gas was not dragging much dust with it. Maybe the surface had been changed by the long journey between stars. Maybe the object's shape and spin made it reflect light in ways that complicated the picture. Every explanation had to fight the same problem. We were trying to solve a physical object without ever seeing it up close. That is easy to forget. Oumuamua became famous enough that people talk about it as if we had a clear image. We did not. Scientists had to work with scraps. The path it followed, the way its brightness changed, its reddish color, its strange rotation, and the fact that it seemed to receive a tiny push without showing the dust cloud many people expected. Those scraps were valuable. They were also frustrating. The light curve was one of the first clues that something was unusual. As Oumuamua rotated, its brightness changed dramatically. That suggested an extreme shape or an unusual surface reflection. A long stretched object could do that. A flattened shard might also explain some versions of the data. A tumbling body with strange surface properties could complicate things further. So the famous cigar shape was not a photograph. It was an interpretation. That matters because it shows how quickly the public image can become more certain than the science. The story people remember is often a long, alien-looking object racing through space. The real scientific object was more slippery, a small, faint, tumbling visitor whose brightness changed in a way that forced uncomfortable possibilities. The shape was not the only strange clue. Its color was reddish, which made sense for an object exposed to cosmic rays for a very long time. Deep space is not empty in the gentle way people imagine. Radiation slowly alters surfaces. Ice and organic-rich material can darken. A body drifting between stars for millions or billions of years can become a processed relic before it ever reaches a new sun. That is a powerful thought. Oumuamua may have carried the scars of interstellar space on its surface. Not dramatic scars like craters we could see, but chemical and physical changes written into its outer layers. That surface may have helped hide what it really was. Maybe it was icy inside, but dark and dry-looking outside. Maybe its outer crust had been hardened or changed by radiation. As it approached the sun, a small amount of hidden material could have been released without producing a bright, dusty display. This is where the 2023 hydrogen explanation becomes important. The idea is that Oumuamua could have been born as a water-rich, icy body. During a very long stay in interstellar space, cosmic rays penetrated the ice and produced hydrogen trapped within it. Later, as the object passed near the sun, warming allowed that hydrogen to escape. The escaping gas could create a small push. Because hydrogen would be difficult to detect and might not carry much dust, the object could accelerate like a comet without looking like a normal comet. That is a beautifully strange solution. It turns the missing tail from a fatal problem into a clue. Instead of asking why a comet had no visible tail, the explanation asks whether we were seeing a comet-like process with the wrong kind of gas and the wrong kind of surface. The object was not impossible. It was unfamiliar. That distinction is everything. Science does not need Oumuamua to be alien for it to matter. A natural interstellar fragment, altered by cosmic rays, warmed by the sun, and pushed by invisible escaping hydrogen, is already one of the strangest objects ever detected in our neighborhood. The alien version is loud. The natural version is deeper, because it tells us the galaxy may be full of fragments like this. Every young star system is messy. Planets form inside disks of dust, gas, rock, and ice. Giant planets can scatter smaller bodies. Close encounters can throw debris outward. Some fragments remain bound to their stars, while others are ejected into interstellar space. Once ejected, they can drift for vast periods of time. A piece of one star system can become a wanderer. If that is common, then interstellar space may not be empty darkness, with only stars separated by nothing. It may contain countless small bodies moving between stellar systems. Icy shards, rocky fragments, dead comets, broken planetesimals, and strange processed objects too faint to notice unless one passes close enough to the sun. Oumuamua may not be rare because objects like it are rare. It may be rare because we caught one. That thought changes the emotional weight of the story. The object was not only a visitor, it was a sample of a hidden population. A hidden population of things moving through the galaxy without names. Some may have formed around stars that no longer exist. Some may have been thrown out during violent planetary rearrangements. Others might carry chemistry from worlds and disks we will never see. Not life, not a message in the intentional sense, but matter, actual matter from somewhere else. Light from other stars reaches us every night. That already feels ordinary because we are used to it. Oumuamua showed something more physical. It suggested that the solar system can receive not just light from other stars, but objects from them. A piece of another place can cross into our own. That should feel enormous, because we cannot travel to most star systems. We cannot send probes easily across interstellar distances. Even the nearest stars are too far for ordinary exploration. Yet the galaxy itself may occasionally send fragments through our neighborhood. It happens briefly, randomly, and usually without giving us enough time to prepare. That is why the next interstellar object matters so much. After Oumuamua, astronomers found another confirmed interstellar visitor, 2I Borisov. This one looked much more like a normal comet, with a visible coma and tail. Borisov was easier to understand in some ways, and that made Oumuamua look even stranger by comparison. One interstellar object behaved like an obvious comet. The first one refused to look normal. So what was Oumuamua? Was it unusual among interstellar visitors? Or did we simply catch it under bad conditions? Did its long journey change it? Did its surface hide its ice? Did its shape make the data look more extreme than it really was? Those questions remain alive because the object is gone. That is the central pain of the case. The more interesting the object became, the less time we had. There was no spacecraft waiting, no planned mission, no way to intercept it. We could only watch it fade into the dark. A visitor from another star system entered our sky, and we were late. That missed opportunity may be the most important lesson, because the next one could be different. A future survey telescope might find an interstellar object while it is still approaching the sun. If that happens, scientists could study it for longer. They could watch how it changes as sunlight warms it. They could search for faint gases before the object becomes too dim. A fast mission might even be possible someday, if the object is discovered early enough and passes through the right region of space. That would change everything. A close image would settle questions that Oumuamua left open. Shape, surface, rotation, jets, chemistry, dust, ice, composition, history. One clear photograph might do what years of debate could not. But Oumuamua did not give us that. It gave us the opposite. A first visitor with no close-up. A path that proved it came from outside. A strange push. A missing obvious tail. Enough evidence to make it real, and not enough to make it simple. That is the second layer of this story. Oumuamua was not just strange because it came from beyond the solar system. It was strange because it sat between categories. Asteroid-like in appearance, comet-like in motion, interstellar in origin, faint in the telescope, gone before we could catch up. The object did not need to be artificial to be disturbing. It only needed to be real, rare in our observations, and poorly understood. Sometimes that is enough to make science feel almost impossible. Now imagine Oumuamua before we knew its name. Not as a point on a chart. Imagine it as a small, dark body moving through a silence so large that the solar system would look like a brief, warm accident. Somewhere around another star, long before it entered our sky, a fragment formed or broke away. Maybe it began inside a disk of ice and dust around a young star. Another possibility is harsher. It could have been torn from a larger body during a violent encounter. Over time, collisions, radiation, and gravity may have changed it until its original story became almost impossible to reconstruct. Then something threw it out. A giant planet could have scattered it. A close gravitational encounter could have changed its path. A young system full of unstable orbits could have ejected it into interstellar space. After that, Oumuamua no longer belonged to a star. It had no sunrise, no seasons, and no parent world nearby. It was just a small, dark body moving between stars. That image is simple, but it is hard to hold in your mind. Between stars, distances become almost absurd. The sun's planets feel far apart to us, but compared with interstellar space, the solar system is a small pool of warmth. Oumuamua crossed a region where no familiar sky existed, no planet held it, and no star claimed it. Cosmic rays struck its surface for ages. Its outer layers may have darkened and reddened. Any ice inside it may have changed slowly. If the trapped hydrogen explanation is correct, then the long, cold journey did not simply preserve the object. It helped create the mystery we later saw. That is the part that makes Oumuamua feel like a true science story. The journey was not just background. The journey may have altered the evidence. By the time it reached our solar system, Oumuamua was no longer just a fragment from somewhere else. It was a fragment that had been processed by deep time. Then, by chance, it crossed the path of the sun. That chance is almost ridiculous. Space is enormous. The solar system is small compared with the gulf between stars. Earth is smaller still. Human astronomy has only been capable of detecting faint, fast-moving visitors like this for a short time. Yet during this narrow window of human history, one passed close enough to be noticed. It did not announce itself. It did not slow down. The object simply entered the sun's light, curved through our neighborhood, and continued outward. When we found it, the clock was already running. Every night mattered because the visitor was getting farther away. Astronomers had to observe quickly, compare data quickly, and revise ideas quickly. There was no chance to build a mission. There was no time to wait for a better angle months later. The investigation felt less like examining an object and more like trying to read a license plate on a car that has already passed you at high speed in the dark. You can catch something. You cannot catch everything. That is why Oumuamua became more than a scientific object. It became a symbol of the thing we almost missed. For centuries, people imagined that the solar system might sometimes be visited by debris from other stars. The idea made sense. Planetary systems form violently. Material gets thrown out. The galaxy should contain wanderers. But before Oumuamua, that was not the same as seeing one. Then it happened. The first known interstellar visitor passed through the same solar system as Earth, and we were not ready to meet it properly. That may sound disappointing, but it also changed the future, because now we know what to watch for. New survey telescopes can scan the sky more deeply and more often. Future systems may discover interstellar objects earlier, while they are still approaching rather than already leaving. The next one could be brighter, slower, larger, better placed, or stranger. The next visitor may already be on its way. That possibility is the hope hidden inside the frustration. Oumuamua left with its secrets, but it taught us how badly we need to be ready for the next visitor. A future interstellar object might be tracked for months before it reaches its closest point to the sun. Scientists could watch it warm. They could search for faint gases. They could measure its rotation while it is still bright enough. With enough warning, even a spacecraft mission becomes less impossible. Imagine that. Not a telescope point, a close image, a real surface, a body from another star system, photographed as it passes through our own. That would be one of the most extraordinary scientific moments in modern astronomy. No alien message required. No artificial object required. Just a piece of another planetary system, finally seen clearly. That is why the Oumuamua story should not be trapped in the question of whether it was alien. The bigger idea is more important. Our solar system is not isolated. It is part of a galaxy where star systems throw material into the dark, and sometimes that material crosses another star's territory. The galaxy is mixing, slowly, randomly, mostly invisibly. Oumuamua made that invisible exchange visible for a moment. A small object from somewhere else entered the region where our planets orbit. It passed near the sun. It gave us a few clues about its shape, color, motion, and origin. Then it became too faint to follow in detail. That is not a complete answer. It is a doorway. The next question is how many more are out there? No one knows the exact number, but the discovery implies that interstellar space may contain a vast population of small, drifting objects. Most would be too dim to detect from Earth. Many would never come close enough to the sun. Some may pass through the solar system and remain unnoticed because they arrive at the wrong angle, at the wrong distance, or at a time when no instrument is looking in the right place. That thought changes the solar system. It means our neighborhood may have visitors we never see. The terrifying part is not that Oumuamua came once. It is that we have no idea how many came before it. A dark fragment could pass far beyond Saturn and vanish without a headline. Another might cross the outer solar system too faint for current surveys. One could pass closer in the future and become the next major mystery. Oumuamua may have been the first one we confirmed. It was almost certainly not the first one that came. This is where the story becomes larger than one object. Between stars, there may be countless fragments carrying the chemical memories of other systems. Some could be dry and rocky. Others may be icy, organic rich, or altered by radiation in ways we do not yet understand. A few may preserve clues from the early formation of planets around stars we will never visit. They are not messages in the way humans usually mean the word, but they are records, physical records. A small object drifting through the galaxy can carry information about the place it came from, even if no one intended to send it. That is what makes Oumuamua so valuable. It was not a signal. It was matter, a physical postcard from an unknown address, damaged by time, brief in our sky, and hard to read, but real. Maybe that is why people could not stop talking about it. The object touched several fears at once. The fear of missing something important, the fear of not knowing what entered our neighborhood, the fear that science can be accurate and still incomplete, and the fear that the universe can show us something once and never repeat it. There is also excitement in that uncertainty, because Oumuamua proved that discovery is not finished. Even inside our own solar system, after centuries of watching the sky, a completely new class of object can appear. Not a new theory, not a new interpretation of old data, an actual visitor moving through our space. That kind of discovery is rare, and it should make us a little more humble. The real version does not need exaggeration. A visitor from outside the solar system came through. It moved in a way that made scientists look twice. It showed no easy tale. It may have been pushed by gas we could barely see. It may have been an icy body changed by cosmic rays. It may have carried the scars of another planetary system. Then it vanished into the dark before we could send anything close. There is no need to pretend we know more than we do. The uncertainty is the point. Science does not always end with a locked answer. Sometimes it ends with a sharper question. Oumuamua gave us one. If one object from another star system passed through while we happened to be watching, how many passed before we were ready? How many crossed the solar system when Earth had no telescopes? How many will cross after us? How many are moving through the dark right now, invisible until the angle, speed, and sunlight make them briefly appear? That is where the title becomes more than a hook. Something entered our solar system. Then it vanished. The sentence sounds simple, but behind it is a much bigger truth. The sun does not sit inside a sealed kingdom. The space between stars is not an empty wall. The galaxy is moving, mixing, scattering fragments into darkness, and occasionally one of those fragments cuts across our sky. Most will never matter to us. One did. For a short time, a piece of somewhere else passed through the light of our sun. We noticed it. We measured what we could. We argued about what it meant. Then we lost it. And somewhere beyond the reach of our telescopes, Oumuamua is still traveling. It is not coming back. It is not waiting for our explanation. Its real shape, its real surface, and its real origin are moving away from us into interstellar space. Maybe one day another object will arrive early enough for us to meet it properly. Maybe the next visitor will show what this one refused to reveal. But Oumuamua will remain the first. The object we noticed too late. The visitor that entered our solar system, then vanished.